Hello and welcome back to our chemistry video series. In this video we will solve question 3, paper 42, February March 24. Let's start. This question is about acids, bases and alkalis. Table 3.1 shows the pH values of some substances. In this table, there are 5 substances with different pHs. Sodium hydroxide with pH 14, calcium hydroxide with pH 10, water with pH 7, ethanoic acid with pH 4, nitric acid with pH 1. Letter A. Defines the term base. In a previous video about acids, we said that acids are proton donors. They donate their protons into solution. Which substance accepts these protons? The substance that accepts these protons is considered a base. In this equation, water H2O accepts the proton of HCl, okay, and change into hydronium ion H3O plus 1. So water is considered a base. What is meant by base? Base is a proton acceptor. Letter B. State what is meant by the term alkali. There is big difference between alkali and the base terms. Look at this figure. Bases include alkalis, but alkalis doesn't include bases. What is the meaning of this statement? Here, bases divided into 2 groups, soluble and insoluble in water. Bases which are soluble in water are considered an alkalis or alkalis, while bases which are insoluble, they only represented as bases, okay, not alkalis. So all alkalis are bases, but not all bases are alkalis. This is the rule. Finally, what is meant by an alkali? An alkali is a soluble base. Letter C. Thymolphthalene is an indicator. See the color of thymolphthalene and sodium hydroxide NaOH and ethanoic acid CH3COOH. Firstly, NaOH with pH 14. It is one of the strongest alkalis. What's the color of thymolphthalene in alkalis medium or base medium? Look, it turns blue, so the answer blue. What about if thymolphthalene added to beaker containing or flask containing an acid like ethanoic acid? It has colorless appearance, okay, with pH 4, so it has colorless appearance. Letter D, single I. Use the information in table 3.1 to identify the substance with the highest concentration of protons for H plus ions. Explain your answer, substance and the explanation. Let's analyze the table, okay, into different categories. Sodium hydroxide with pH 14 and calcium hydroxide with pH 10, they are considered alkalis. H2O is neutral with pH 7, while the last 2 substances, ethanoic and nitric acid, are acids. So acids donate protons. Which one of them? Here 2 acids, ethanoic and nitric. Which one releases more protons in solution? Ethanoic with pH 4 or nitric acid with pH 1? This figure represents pH scale and accumulation of protons along this scale. As we move from left to right by increasing pH degree, what happens to proton ions? It decreases. So which substance with the highest concentration of protons of sure which has lowest pH? Nitric acid here has lowest pH equal 1. Okay. Letter D double I. Name an indicator which can be used to identify the substance with the highest concentration of protons, H plus ions. We use universal indicator. Universal indicator paper can be used to check and determine in precise degree the pH value of solution. Okay, look at in acidic medium. Here 3 different degrees of pHs with 3 different colors. So pH paper or universal indicator paper can check and identify which substance with the highest concentration of protons. What about litmus paper? Litmus paper just is used to determine which substance is acidic and which one is basic or alkaline. Okay, it can't distinguish. It cannot distinguish between different pHs in acidic medium and different pHs in alkaline medium. Okay. Letter E. Complete the equation to show the dissociation of ethanoic acid CH3COOH in aqueous solution. What about ethanoic acid? Ethanoic acid is an organic acid. All organic acids are weak or very weak acids. Here ethanoic acid is weak acid. What about its dissociation? It is partially dissociates into acetate group and protons. Then reversibly these protons recombine with acetate group to form ethanoic acid. Again, it has partially dissociation degree. Okay, it releases less number of protons. It's considered weak acid. Here, if we given 100 molecules, for example, 100 molecules of HA of ethanoic acid, only less than 10% of molecules dissociates into proton, okay, that combine with water to form hydronium ion and negative ion. The remaining, the most molecules of the substance is still represented as complete molecule of ethanoic acid. So this partially ionized. Okay, in beaker containing ethanoic acid, we found most of molecules are found as complete molecule without dissociation. Little molecules of ethanoic acid dissociate into protons and an anion. Letter F. Write the ionic equation which represents a neutralization reaction between any acid and any alkali. Let's choose certain equation from the same exam and same question, like this equation. Look, 2 moles of nitric acid react with 1 mole of calcium hydroxide to form salt and water. This is the definition of neutralization. Reaction between acid and an alkali to form salt and water. Let's analyze this equation step by step. The same equation, 2 moles of nitric acid dissociate into 2 moles of protons and 2 moles of nitrate ions. 1 mole of calcium hydroxide dissociate into 1 mole of calcium ions and 2 moles of hydroxide ions. The salt in aqueous form, it completely ionized into 1 mole of calcium ions and 2 moles of nitrates and 2 moles of water without ionization. Okay, water doesn't dissociate. There are some ions present on both sides of the equation. We call this ions that repeated on both sides as spectator ions. We can cancel the spectator ions like nitrate present on both sides and the calcium ions present on both sides. So rewrite the equation after cancelling. Look, 2 moles of protons, 2 moles of hydroxide ions, combine to form 2 moles of water. By simplifying this equation by dividing 2 to obtain net ionic equation for neutralization. Any neutralization between acid and any alkali forms this ionic equation. H plus in aqueous form plus OH minus in aqueous form combine to form water in liquid state. This neutralization reaction, while in your exam just only write the final net ionic equation, okay, to obtain 1 mark. Letter G. Dilute nitric acid HNO3 react with aqueous calcium hydroxide CaOH by 2 as shown. 2 mole of nitric acid react with 1 mole of calcium hydroxide to give 1 mole of calcium nitrate and water. 20 cubic centimeter of 0.0150 mole per liter calcium hydroxide, okay, react with 25 cubic centimeter of nitric acid. Calculate the concentration of nitric acid in gram per liter per cubic decimeter. Use the following steps. Calculate the number of moles of calcium hydroxide solution used. We need to draw this triangle to show the relationship between number of moles, amount of substance in moles, and volume and concentration of the same substance. Here's a question about calcium hydroxide. What about the data given in this question? 20 cubic centimeter, but the rule use the volume of the substance expressed in cubic decimeter. So we have to convert 20 cubic centimeter into cubic decimeter. How come? By dividing 1000. 20 over 1000, okay, this conversion factor. Now what about concentration? Concentration 0.0150 mole per liter. So to calculate number of moles of calcium hydroxide, we have this equation. Number of moles equal concentration times volume. By compensate the figure, okay, we obtain 3 times 10 to the power minus 4 mole. Okay. Determine the number of moles of nitric acid which react with calcium hydroxide solution. From the equation provided in exam, look at the equation firstly. How many moles of nitric acid? 2 moles. How many moles of calcium hydroxides needed for reaction? 1 mole. So from the equation given in your exam, we can extract mole ratio. 2 moles of nitric acid and 1 mole of calcium hydroxide. So the ratio 2 to 1. Okay, but already we have no 1 mole of calcium hydroxide. In the last step of calculation, we obtain only 3 times what? 3 times 10 to the power minus 4 mole. So what about how many moles of nitric acid? It represented by X. By cross multiplication we can, or by multiplying times 2, we can obtain the number of moles of nitric acid. Nitric acid equal 2x of calcium hydroxide. So 2 times 3 times 10 to the power minus 3 mole. Okay, the last answer, last figure equals 6 times 10 to the power minus 4 mole. Okay. Third point, calculate the concentration of nitric acid in mole per liter. In mole per liter. The same triangle, amount in moles of substance is given by knowing concentration and volume. Okay, so he asked about concentration of nitric acid. We are obtain the amount of moles of nitric acid in last step as 6 times 10 to the power minus 4. What about the volume taken in the introduction of the question? Okay, at the beginning of the question, 25 cubic centimeter of nitric acid is used for neutralization. So we convert this figure into cubic decimeter. So concentration equal amount of moles divide volume in liter. Amount in moles, okay, divide volume per liter or cubic decimeter. So by compensation we obtain these figures, and the last figure equal 2.4 times 10 to the power minus 3 mole per liter. Okay, calculate the concentration of nitric acid again, but in gram per cubic decimeter. We obtain in the last step the concentration of nitric acid in mole per liter. Now we need to convert this mole per liter into gram per liter also. How come? Look, firstly, concentration gram per cubic decimeter equal concentration mole per liter, okay, times MR. What is meant by MR? Relative molecular mass of HNO3. So to convert any substance when it is given by mole per cubic decimeter, we have to multiply by what? By MR to produce the concentration with gram or in gram per cubic decimeter. So what about MR? MR from periodic table given in your exam. We can check MR by HNO3 is formed from 1 atom of hydrogen, 1 atom of nitrogen, and 3 atoms of oxygen. What about their masses? Hydrogen with mass equal 1, okay, atomic mass 1. Nitrogen with atomic mass 14, while oxygen with atomic mass 16. So 1 plus 14 plus 3 times 16 equals 63. So MR equals 63. We can compensate now 2.4 times 10 to the power minus 3 mole per cubic decimeter times 63 to give what? To give the last figure 1.51 gram per cubic decimeter. This is the final answer. Okay, thank you for watching. See you next video inshallah. Bye bye.